So we've got a graph given to us of f prime from -6 to 5. And we know that f of -2 is 7. And we know that this is a semicircle, and we know that these other three little pieces here are line segments. So the first thing we want to find is the value of f of -6 and the value of f of 5. So how are we going to do that? How do you guys go about that?
Set up the integral with when they give the value of f of -2 equals 7. So you do like the integral from -6 to -2 of f prime of x equals f of -6 minus f of -2. And then since you know the other value, you can solve for the one.
Right. That's all good. That all sounds nice. If you don't want to set it up initially like that, you can always just do 7, this value that you know, plus the integral from the value that you know to the value that you're looking for of your function. So that'll also work. And I mean, that's how I normally would set these up, but the way you said is also good. And so we're looking for the integral from -2 to -6, but that means we're going backwards. So we'll want to flip the limits and make it a negative instead. And as we do that, the integral from -6 to -2 of f prime, that's just this triangle, right? So 1/2 of the base times the height, which is 1/2 of 2 times 4, which is just 4. So we got 7 minus 4, we got 3. Any questions with that? All right, and for 5, it'll just be 7 plus the integral from -2 to 5 of f prime. And in order to figure out that integral, all we need to do is integrate from -2 to 5. And so this bottom piece here is a semicircle with a radius of 2. So that should be 1/2 of pi times the radius squared. And then this is just a triangle with a base of 3 and a height of 2. So that should be 1/2 of 2 times 3. So that piece should be 3. This piece should be 2 pi. So we should end up with 7 plus, and then since this is below the x-axis, that's a -2 pi. And then this should be a plus 3, and we get 10 minus 2 pi. Any questions there on that one?
For the first one where you found f of -6, why'd you do from -2 to -6 instead of -6 to -2 to where you had to flip them? Were you like forced to do that?
Yeah, so if we look at the value that we already have, right, we know that at -2 it's 7. So we just do 7 plus the integral from -2 to any x value up here, because that, right, remember when we do the fundamental theorem of calculus, that's what tells us if we do -2 to -2, it gives us 0. So we do -2 to any value up here, plus this 7 should give us the value of it. This lower limit always has to be positive, or not positive, it has to be our constant that we know. And then this, this thing outside has to be the value of the function at that. Does that make sense?
Okay, thanks. Yeah.
All right. Second part of this here is we want to know on what intervals is f increasing. Oh, sorry, this is also, I'll give you guys a point breakdown here. So for the first one, you got 3 points, 1 if you remember to use the initial condition, and 1 for each of those. Okay, so then if we're looking for when is when is f increasing, f should be increasing whenever f prime is positive. Well, in order to figure that out, we just have to look at the graph. F prime is positive here and here. And because they always ask you to indicate increasing and decreasing intervals with brackets, should be -6 to, what is that, -2? Yeah. And 2 to 5. And that should be it. And that's just 1 point for that. No,
If you
no,
use parentheses,
that's
use
2 points.
parentheses on that, would you still get it or no?
They always say that you are supposed to indicate increasing and decreasing intervals using brackets. So I think that they will not give you the points if you don't put brackets.
Okay. And then what was the other thing? It was like points of inflection are like parentheses, or it was like one of them is brackets and one is parentheses.
Anytime you're talking about concavity, intervals of concavity, parentheses, no matter what, increasing and decreasing intervals, brackets, unless it's at infinity. If it's at infinity, then it's still a parenthesis.
Okay.
Yep. Everybody good there? All right. Part C, looking for the absolute minimum on the closed interval -6 to 5. So if we're talking about an absolute minimum on a closed interval, we need to test the endpoints, and we need to test any critical values of F. So critical values of F will be places where F prime changes sign. So F prime goes from positive to negative here at -2, and it goes from negative to positive there at +2. Now we should know that it's definitely not going to be at -2, because if F prime is going from positive to negative, that means the function goes from increasing to decreasing. So this one we know is a max, so we don't need to worry about that because it's not going to be the absolute min. And on top of that, we know the value of it, it's 7. And then we already figured out the value at -6. The value at -6 was 3. And we already figured out the value at 5. That was 10 minus 2 pi. So we just need to figure out the value at 2. So f of 2 ought to be 7 plus the integral from -2 to 2 of f prime. And the integral from -2 to 2 is just this 1/2 of pi times 2 squared. That's just your -2 pi. So that's 7 minus 2 pi. And I think it's pretty obvious that 7 minus 2 pi is the smallest of those 4 values. And therefore, that's where our absolute minimum is. Good or no?
Wait, why is the -2 a max again?
You can, I mean, okay, so 2 things. One, you didn't need to note that it was a max ahead of time. You could have just found your value of it, which was 7, and realized that it was more than 7 minus 2 pi. But we know that it's a max because the derivative, f prime, goes from positive to negative at that point, which means the function goes from increasing to decreasing.
Okay, cool.
Does that make sense?
Yeah.
All right, and for part D, we want to find f double prime of -5 and f double prime of 3. So that's just the slope of f prime. Well, at -5, it's just this linear piece here. So you'll just do a rise over a run, right? This is what, -2 and 4. So that should be -1/2. And then at 3, we would say that the derivative of f doesn't exist because the derivative of f prime, f double prime doesn't exist because we have a corner there. And you could be more specific and say the derivative from the left, the slope from the left, and the slope from the right are not equal. And since slopes are limits, the limit from the left is not the same as the limit from the right, and therefore it doesn't exist. Good or no?
So
What was
for
the point
questions
breakdown?
like C, for questions like C, when it says justify your answer, is like our table of values enough justification, or do we have to like write out an explanation?
No, your table of values is plenty of justification as long as you've shown how you got each of these values. I know my work's a little bit of a jumble, so I mean, you'd have a big giant space to do the work, so you'd write out the work for each piece of it.
Oh, you have to write out the work. Okay.
Yeah, I mean, for some, like for -2, you don't. -2 is 7. They just give you that. Just put it in the chart. You know, for -6 and 5, you wouldn't need to because you already did it up there in part A. So if you already did it in an earlier part, you don't need to re-show the word. You just throw the values in your chart. But you would need to show it for 2. So you need to at least show this for part C.
Okay, thank you.
And yes, Alex, you were asking about the point breakdown, right? For the last 2. So 2 points for part C, 1 for making sure you tried x equals 2, and then 1 for getting the final answer. And then the last thing was 2 points, 1 for each. So 1 for that and 1 for that. Good?
How many was C again? How many points?
C was 2. One for noting that 2 was a potential value that you should have used to test, and then 1 for figuring out that it was at 2, that it was 7 minus 2 pi.
Okay, thanks.
Okay. All right. So next one here, we've got the graph of f given to us, and then g of x is the integral from 2 to x of f. So we want to first know, does g have a relative min, max, or neither at x equals 10? And so if g has a min or a max, we need to figure out what g prime is. Well, g prime is f of x. And so we want to know, does f of x equal 0, or is f of x undefined at 10? Well, the answer is yes, it equals 0. But does f prime change signs? It does not. Right? Just because the derivative is 0 does not mean that you definitely have a max or a min, right? In this case, f prime, or sorry, not f prime, but I keep writing. Sorry, this should be g prime, does not change signs. So g prime, which is f, is negative, and then it's still negative, which means the function g is decreasing, and then it continues to decrease. Everybody good with why part A is neither?
Yeah.
All right. Part B, and that was worth 1 point. 1 point for the answer. They also gave 1 point just in general for noting that g prime was f of x somewhere throughout the entire problem. All right, part B, we want to know, does g have a point of inflection at x equals 4? So that means we're interested in g double prime, which should be f prime. And the question is, does the derivative of f change signs at 4? Well, at 4, f prime goes from being positive to being negative, right? F prime goes positive to negative. So yes, it does have a point of inflection there. Good or no?
So what evidence did you have to show to prove that? Did you just have to say like you said, like g double prime equals f prime, or?
It's saying g double prime equals f prime, and f prime goes from positive to negative. And that's plenty of justification.
Okay.
Yep. And that was also worth 1 point. All right. For part C, we're looking for the absolute min and the absolute max of g from -4 to 12 on a closed interval. So we got to remember that anytime we have a closed interval, we need to check the endpoints and any critical values. So once again, we're looking for when does f equal 0? Well, f equals 0 at -2. So let's put our endpoints. Hold on 1 second. Okay, sorry about that. So -2 is one possibility here. Our derivative of g, which is f, goes from negative to positive here. There's a sign change, right? So negative to positive means that this could potentially be a minimum. We'll find out in a minute. Here at 2, f is equal to 0, but our derivative of g, f, stays positive. So we don't need to bother checking that one because there's no sign change, which means it can't be a max or a min. Here we go from a derivative is positive to the derivative is negative, right? F being the derivative. So this at 6 is possibly a max. And then at 10, our derivative is negative and stays negative. So that one doesn't make any sense. No sign change, so it couldn't possibly be. And then 12 as well. All right, everybody good with the values that we're setting up in our chart to begin with there? Why we picked those 4 and ignored 2 and 10? Hopefully.
Can you just go over that really quickly one more time?
Yeah, so we picked -4, we picked 12 because those are our endpoints of our interval. So of course we picked those. And then we need to look at every other place where the derivative of g, because that's what we're interested in, is equal to 0. The derivative of g is f, so we look where f is 0. So at -2, f is 0. And remembering that f is the derivative of g, right? I'm going to write that over here. Derivative of g. So that means that the derivative of g goes from negative to positive, which means that g goes from decreasing to increasing, which means it could be a min. At 2, the derivative of g is positive and stays positive, so there's no sign change, so no max or min. At 6, the derivative of g goes from positive to negative, which means that g goes from increasing to decreasing, so that's a potential max. And then at 10, the derivative of g goes from negative to still negative, so that one we don't have to worry about.
Okay, thanks.
Is that good now? Yeah.
Yeah.
Okay. Perfect. All right, so now we'll find all of those values. So g is the integral from 2 to x of f of t. All right, so we need to first find the integral from 2 to -4 of f. And the integral from 2 to -4 should be the same as the opposite of the integral from -4 to 2 of f. And if I'm going to go from -4 to 2, well, let's see, this is a negative value. This is 1/2 base times height, so that's -4. So don't forget there's already a negative. So then -4. And then this piece up here is positive with a base of 4 and a height of 4. So 1/2 4 times 4, or positive 8. And so we end up there with -4 plus 8 is 4, but we take the opposite of it as -4. So our value of g at -4 is -4. Good or no? Everybody good with -4?
Yeah.
All right. Then we'll do from 2 to -2, or the opposite of -2 to 2. And for that one, we are just looking for the opposite of this integral. And this one was 1/2 base times height for that triangle again, which is just the opposite of 8, or -8. Everybody good with the value at -2?
Yep.
All right. Value at 6. So we're going to do an integral from 2 to 6 of f. So 2 to 6, that's all positive, right? So this area should be 1/2 base times height, which is 8. Everybody good there? Hopefully, everyone's good.
Yeah.
Okay, and then from 2 to 12, this is a positive 8. This cancels out. That's a -8. So we got 8 minus 8. And then this is 1/2 base times height. So that's a base of 2 and a height of 4. So that's another -4 that we're below. So we should end up with -4. And then we just look for what's the absolute max. Well, the absolute max is 8 at x equals 6. And the absolute min is -8 at x equals -2. Good or no? Any questions or issues there? All right. Part D, we want to find all intervals for which g of x is less than or equal to 0. And so we know that from -4 to -2, it was less than or equal to 0, right? And then we got to figure out where it stops being negative. Well, it should stop being negative when we get to what value? When we get to 2, right? So let's see, I'll write this over here. -4 to -2. And, oh, sorry, not -2, +2. And we know that it's 0 when we get to 2 just because g is the integral from 2 to x. So if I go 2 to 2, this is where I become 0 again, right? Does that make sense to everyone for the first part of that? And then it's positive for all of this, 8 units. Then it loses 8 units. So from here to here, that all cancels out to be 0. And so then we're negative again from 10 to 12 because we're adding in stuff below the x-axis. Good or no? Let's see, that was worth 2 points. This was worth 4 points here. One for trying -2, one for trying 6, one for showing the endpoints, and one for the final answer.
Wait, I just don't understand why the first interval ends at 2. Can you explain that one more time?
Yeah, so remember that g of x, where is it? It's written somewhere. There it is. G of x is the integral from 2 to x. So if I'm doing the integral from 2 to 2, what does that become?
0.
0, right? And so here I had some negative value here, right? This was -8 if I just did -4 to -2. Sorry, if I did the value of, if I just did the value of g up to -2, it was -8 was the integral, right? And so then to get from -2 to 2, I add in 8 more units. So that's going to take me from the -8 that I was here to the 0 that I should be here. And so that's why it stops at 2, because then we start adding in more positive area over here.
Okay.
Does that make sense or no?
Yeah.
Okay. Cool. Any other questions on that one?
For the area from -4 to -2, wouldn't it be smaller than -2 to 2? So if you were to add them, it would be like positive.
Sorry, say that again. The area from where to where?
-4 to -2.
The area from -4 to -2 is -4.
Yeah. So when you add 8 to that, would that not be like +4?
It would be, but you have to keep in mind that the area from -4 to wherever you're going is not what g equals. G equals the area from 2 to wherever you're going. So g of -4, as we wrote somewhere over here, g of -4 is this integral, the integral from 2 to -4 of f. That's g of 4. And so it's not just about the area underneath the curve, but it's also has to do with what the limits of integration are. So you got to go from 2 to -4, not -4 to 2.
I see.
Does that make sense?
Yeah.
Cool. Any other questions on that one? let's look at the next one. I asked you guys to do this one already, right?
Yeah.
Okay. Cool. So a couple things this one tells us. First off, that we've got f prime is our graph, and it's the derivative of the twice differentiable function f from -3 to 4. It's got horizontal tangents at -1, 1, and 3. So we know that these are local mins and maxes. We also know that this area from -2 to 1 is 9, and this area from 1 to 4 is 12. And first thing we want to know is all of the x coordinates when f has a relative max. So f can only have a relative max potentially at an endpoint or at a place where the derivative is 0 or undefined. Well, our derivative is never undefined, but our derivative is 0 at -2, 1, and at 4, which is also an endpoint. And we should also look at -3 because that's an endpoint. We could have a relative max at an endpoint as well. But if we think about this, f prime is our graph, which means f prime is positive from -3 to -2, which means that f is increasing, which means that I'm not going to have a relative max at -3, right? Because f is increasing from -3 to -2. So I can ignore that one. Here, my function goes from increasing, and then my derivative is negative, so then it goes to f is decreasing. So if my function goes from increasing to decreasing, I could have a max there, right? So we're going to say there's a relative max at x equals -2. And then here at x equals 1, f goes from, or f prime is negative, so f is decreasing, and then f prime is still negative, and therefore f is still decreasing. So we're not going to have a relative max or a relative min here. And then at 4, since f is decreasing down to that value, we're not going to have a maximum at this endpoint either because we're decreasing down to that. It's going to be a minimum. So just the one value at x equals -2. Any questions on that one? Sorry, that I just was looking that back up again. That's actually worth 2 points. Not 1, 2 points there.
Can it not be -3 or 4?
Yeah, so that's what we were just saying here. It can't be -3 because my function is increasing from -3 to -2. Right, so I mean, if I were to just sketch, let's just do a sine chart actually for this, if that might help. -3, -2, 1, and 4, right? What's happening to f prime here? F prime from -3 to -2 is positive, which means f is increasing. Right, from -2 to 1, f prime is negative, therefore f is decreasing. From 1 to 4, f prime is still negative, therefore f is still decreasing. So my function looks something like that. So the only place I can have a max is at this value at -2. Not at the endpoints, because I'm increasing and then I'm decreasing at the end. Does that make sense?
Yeah.
Cool. Anybody else? Any other questions there in part A?
What was the point breakdown?
It was just 2 points for -2 with a reason. So your reason could be a sine chart, your reason could be a written explanation that the only place where f prime goes from positive to negative is at -2, or anything like that. All right, part B, we want to know on what open intervals between -3 and 4 is f concave down and decreasing. So if f is going to be concave down, that means that f double prime needs to be less than 0. And if f is going to be decreasing, that means that f prime needs to be less than 0. So first off, f prime is only less than 0 from -2 to 4. Right? Effectively from -2 to 4. I mean, really, it's not at 1, but that's fine. We'll worry about that if it's a problem in a minute. And then f double prime is less than 0 whenever the slope of f prime is negative. Right? This is slope of f prime is less than 0. If the slope of f prime is less than 0, that should tell us that f prime is decreasing. So where is f prime decreasing? Well, it's decreasing from -3 to -1, and also from 1 to 3. And so we just look for what is the overlap of that. Well, it's negative and decreasing from -2 to -1, as well as from 1 to 3. And 2 points for having the right intervals there. Good or no?
Good.
All right. Part C asks us for points of inflection of f. So points of inflection of f should be when f double prime changes signs. And f double prime will change signs any place where f prime goes from increasing to decreasing, or decreasing to increasing. Not necessarily every time, but that's the places where it could happen. So f prime goes from decreasing to increasing here at -1. Then it goes from increasing to decreasing there at 1. And then it goes from decreasing to increasing there at 3. So -1, 1, and 3. And that's 2 points for all of those. Any questions there on that? All right. Yeah, you could have used a sine chart to show that, sure. You could have just said f double prime is, you'd have an f double prime is negative from -3 to -1. F double prime is positive from -1 to 1, and then negative from 1 to 3, and then positive from 3 to 4, and shown that. Yep, that would work too. All right, part D says that given that f of 1 equals 3, so that f of 1 equals 3, we're going to write an expression to represent f of x with an integral, and then f of 4 and f of -2 is what we want to find. So first off, if we know that f of 1 is equal to 3, we should be able to write that f of x should be equal to the integral from 1 to whatever x value we want of f prime of t dt plus 3. Right, that satisfies this condition that f of 1, if I plug in 1 to this, right, I should get 3. So there's our expression. You actually ended up with 2 points for that, 1 for this and 1 for remembering to use the initial condition. And then 3 points for finding the correct values at the end of f of 4 and f of -2. So f of 4 is the integral from 1 to 4 of f prime plus 3. And the integral from 1 to 4, well, that's just this area, which is -12, since it's an integral. So this will be -12 plus 3. So -9. And then what what was the other one? We wanted to find f of negative 2. That should be the integral from 1 to negative 2 of f prime, which will be the opposite of the integral from negative 2 to 1 of f prime, plus that 3 from negative 2 to 1. That's 9, but it's a negative 9 because it's below the x-axis. And it's a negative of negative 9 and then plus 3. So that one should be 12. Any issues there with either of those? That was worth 3 points. So like I said, 1, 2, and then 3 for getting the correct final answer there. Any issues? Everyone good there? All right. And I believe I also asked you to do this one, right?
Yeah.
Cool. All right, so in this one, we're given a graph of f, and g is the integral from negative 3 to x of f. So g is the integral of this. So we want to find g of 3. G of 3 ought to just be the integral from negative 3 to 3 of f of t dt. So from negative 3 to 3, we've got this nice triangular section to start with, which ought to be 1/2 of the base of 5 times the height of 4. And then minus this little section that's below. Since we know that this piece is linear and it's going from 2, 0 to 4, negative 4, that's every time we go over 1, we go down 2. So this is 2 units by 1. So minus 1/2 of base times height gives us 10 minus 1 or 9. And that was worth 1 point. Good or no?
Good.
All right. Part B is similar to one of the ones in the last one. On what open intervals from negative 5 to 4 is g both increasing and concave down? So if g is increasing, g prime or f needs to be positive. And if it's concave down, g double prime or f prime needs to be negative. So first off, we're looking for when is f positive. Well, when is f positive? F is only positive on those intervals from, what is that, negative 5 to 2. And then when is f prime negative? F prime is negative means that f is decreasing. So that'd be from negative 5 to negative 3 and from 0 to 2. And that was worth 2 points. Good or no?
If you got like one interval but didn't get the other, could those points be like split up, or is it all or nothing?
Let me see here. No, it was all or nothing.
Okay.
It specifically says it says 1 point answer, 1 point reason. And so I feel like if you don't have the 1 point for the answer, you can't. Maybe you could get the reasoning point. I don't know. If you said f is positive and f prime is negative, and then you just only picked one of the intervals, maybe they give you the 1 point for the reasoning, but not the point for applying it for the answer. It's possible, but it's hard to say. Probably up to the discretion of the person looking at your exam. And I don't know how kind all those people will be. So. All right, part C. Part C, we got h. H of x is g of x over 5x, and we want to find h prime of 3. So first off, we need to use the quotient rule to find h prime. H prime of x ought to be 5x times the derivative of g minus g times the derivative of 5x all over 5x squared, right? There's our quotient rule. And if we're looking to evaluate that at 3, 15 times g prime of 3. Now g prime of 3 is f of 3, and f of 3 is -2. And then minus 5 times g of 3, which is 9. And then 15 squared is 225. So we got -30 minus 45 is -75 over 225, which reduces to -1/3. 1 point for -1/3, 2 points for the correct expression for h prime. Good or no?
Good.
Great. All right. And then part D. Let's see. Part D said we got P of x, which is f of x squared minus x. And we're looking for the slope of P at x equals -1. So that'd be P prime, which would be the derivative of this, f prime of x squared minus x. Using the chain rule, we're going to multiply by the derivative of x squared minus x. And if we're looking for that at x equals -1, this ought to be f prime of, let's see, what's that? 1 minus a -1, so f prime of 2 times -3. So what's f prime of 2? We look back over here, the derivative of f at 2 is just the slope of this. That's the slope of -2. So this is -2 times -3, which gives you 6. And that was also worth 3 points, 1 point for the answer, 2 points for the correct expression for P prime. Good or no? Any questions on that one?